So I told you yesterday that one of my goals this year was to bring faith into the classroom. I'm going to read you a longer than needed verse from Psalms. I think it's Psalms 57. Nope, Psalm 51. I'm going to read you verses 1 through 6, but it's really verse 6 that we're going to pay attention to. Okay, so it says, "Have mercy on me, O God, because of your unfailing love. Because of your great compassion, blot out the stain of my sins. Purify me from my sin. For I recognize my rebellion. It haunts me day and night. Against you and you alone have I sinned. I have done what is evil in your sight. You will be proved right in what you say, and your judgment against me is just. For I was born a sinner, yes, from the moment my mother conceived me. But you desire honesty from the heart, teaching me wisdom even there." You can't lie to God. God knows what's going on inside, right? He desires you to be honest in all things. And that is very hard. And I'm going to tie that in right now. If you are stuck on something, what good does it do you if I come around and say, "Okay, who has questions?" And I'm embarrassed. I'm good. In here, you know that you're not being honest with yourself, which then is going to, it compounds. It's the snowball effect. You have a problem, you don't understand it, then all of a sudden you need that problem to do oh man, and it just gets harder and harder and harder until you feel like you're drowning. God doesn't want that. He wants you to be honest from the heart. Okay? Okay. So if you have questions, you got to ask. Number one, everybody has to have the same answers. This is the only one that everybody has to have the same answers. What are the three undefined terms of geometry? Point, line, plane. Those three things cannot have a definition, because in order to try to define those, we have to use the other things. But I can't talk about a point because we can't talk about space because we don't know what space is. There's all these things that we can't define. And then to make a line, we need points, but we don't know what the definition of a point is. And to create a plane, we need space, all these points, and these lines. You can't define them. We can see them. We can understand it. But we can't put words to it. Sounds a lot like faith to me. Yeah. I mean, really, it sounds a lot like faith to me. I try. When I read the Bible, then I had a question today when I'm reading Acts. Okay, so I read Luke, got through Luke, read Acts. So you guys know maybe Acts was written by Luke to Theophilus, the same guy that he wrote the book of Luke to. And I just got through, and now I'm blanking on it. Not Simon, what was the gentleman's name who just went through the trial? Stephen. And Stephen is spouting off all of these things from the Old Testament. And I asked, I did, and I was like, how do these guys know all of this from the Old Testament? I understand the Torah was the 5 books written by Moses, but all of these other writings, how do they know this? And a lot of it was passed down verbally from one person to the next. Some of it's, then they had scribes. Man, there's a lot of faith going on there. To be able to say, hundreds of years ago, this is what happened and was said. And that's why it relates to our Messiah now. I mean, it blows my mind. But anyway, have a little faith with the undefined terms. Okay. Give me an example, Cooper. Give me an example of a line.
Right there. Just going across the ceiling.
Okay, so this little track going across the ceiling. Good. Esther, give me another line.
Lines on the rug.
The lines on the rug. Give me something else, Ella.
The lines on the window.
The lines on the window. Like the window frames, right? Is that what you mean?
Yeah.
This? Cool. Daniel.
I said the light.
The light. Perfect. Lucy.
All mine got said. Oh, wait. Did someone say those things?
Nope. What thing? The like little thumbtack things?
Yeah.
Yeah, absolutely. Are there thousands of other lines in here? Absolutely. Each of these things hanging down is a line, right? The edge of the TV could be a line. The edge of this, the edge of this, the edge of my camera, the top of your desk part right here. All of these, there are infinitely many lines in here that you could describe, right? So, if you only have 3 written down, you just heard a bunch. Maybe write some of them down. Just saying. Okay, 3 examples of intersecting lines. We're going to go around again. Cooper, go.
Those intersecting.
Okay, the tracks.
Yeah, tracks.
So, going back to the same thing you had. So the tracks, good. Esther.
Say the gaps in between the.
Ooh, the desks. What you mean where the desks are connecting?
Yeah.
Cool. This line and this line. Perfect. Ella.
I said that, like, top of the desk line right here and the leg.
Ooh, the leg of the desk and the top of the desk line. Okay, she's not saying the plane. She's saying this edge and the bottom. Good, Daniel.
I said like right here where these 2 points meet on that corner. On the desk.
This?
Yeah.
Okay, so this side of the desk, this side of the desk?
Yeah.
Perfect. Man, I just came over here. A lot of intersecting lines on this thing, right? Lucy. That's not a line. It's not a line. Try again.
All the ones I knew, like.
Look around the room. There's all kinds of things. It's what I love about geometry.
TV.
What about the TV? Oh, the edges. So this line here, this line here. Oh, wow, that's dusty. Wow. Did everybody see that? Oh my gosh. Oh, that makes me want to vomit a little bit. Oh my gosh, yuck, yuck, yuck. I don't like dirt. Like I don't like things to be dirty. Yuck. Oh my gosh. Okay. That's wow. 2 examples of intersecting lanes. Now, this is where it gets a little bit trickier. Cooper.
Yeah, okay, got it.
I was giving you a second to come on back.
That
So you're-
wall and ceiling.
Okay. The side wall and the ceiling. Excellent. Esther.
Floor the wall.
Which wall?
That one.
Yeah, doesn't matter. This floor, this wall. Good. Ella.
The side of the cabinet and the top.
Good. Side of the desk, top of the desk. The whole thing. Daniel.
I said like the wall and the ceiling. Like where they
Yep,
meet.
perfect. Wall and the ceiling. Not where they meet, but the whole wall and the
Or
whole
like-
ceiling.
like
Yep,
this.
they're meeting. Yeah,
Yeah.
they're meeting and forming a what?
A corner.
What is that corner?
The ceiling. The line.
A line. Lucy, don't tell me that everybody's already used all of them.
They did. That's the worst part about going last is that everyone already said everything. And I was gonna say the wall and the ceiling. So there
Okay.
you go.
Try a different wall.
Or
Better
that
yet,
wall.
try the windows.
Or the door and the floor.
Okay, thanks, guys.
Or the bookcase, or the filing cabinet, or the garbage can, or this book stacker thing,
The
or
windows.
this plane and the imaginary plane going down. Because remember, just because we can't see it, there are still planes. Okay? My arm's a plane. It can't extend forever. Right? There can be a plane right in the middle. You have to imagine it's cutting through everything. Good answers, Lucy.
So matter is technically a plane.
What questions do we have? Anybody? Get out your homework, please. You had page 8 and 9, numbers, something, something,
Through
something.
17 odd.
And
then
31 through 37.
What was it?
9 through 17 odd and 31 through 37 odd.
Okay, 9 through 17, 31 through 37. Got it, okay.
I don't remember that now.
I see.
I don't know if it's right.
That's all right. We're going to go over.
Finish that
You. Yes. Okay. I always like to enter in the grades while I'm thinking about it because you all deserve to have your grades. I like to keep grades as updated as possible. You'll see that next week's module is open. You'll also see that you have a quiz next week. Again.
Thursday?
Huh?
Thursday?
Yes, sir. And it shows it in the module, so you'll be able to see that. Everything that you ever need is in modules. Everything you ever need is in modules. Okay, so yeah. So next week, on Tuesday, we're doing section 1.5, because today we're doing 1.3, tomorrow you're doing 1.4. Then we're gonna do 1.5 on Tuesday, and 1.5 on Wednesday. Oh no, it's not on Thursday, it's on Friday. Thursday's a review day.
Oh, I got you.
Then Friday we're going. Okay, now, I need you guys to open, oh no, we're doing the homework. Number 9. It says, name the lines that contain the point K. Now, this is important. when I say line KM and line KL, here's what you need to have written. So here's number 9. If you just have KM like this, it is incorrect.
Gotta have a line on the top.
You have to have the notation. Okay? This is extremely important. Notation in geometry matters. You will get points marked off if you do not have them correct. Now, Mr. H, could I have written MK and LK? Yeah. When we write lines, it doesn't matter. Why? Because they go forever in both directions. So it's going to include all of those points. Okay, but you need to make sure that you are using the correct notation. Okay, which pairs of lines appear to be parallel? So this is number 11. Here's how I would write this. I would write KM, line KM, is parallel to line LN. Okay, these slightly slanted lines that look to be parallel is how we say are parallel. And KL is parallel to MN. I like this song. Okay, questions so far? Is there anyone who missed those? And again, go back to our Bible verse. Please don't just be like, hey, I'm embarrassed. That's fine. You can wait, but make sure that you ask. Number 13, name the planes whose intersection is line AB. Remember, 2 planes always intersect at line AB. Who thinks they know? What 2 planes? Go ahead, Esther.
Plane M.
Plane M and plane N. Plane M, plane N. Does anybody need me to come around and kind of show you in your book? Okay. Number 15, name 3 concurrent. 3 lines that intersect at point H. Ready? Line AH. They all are going to have H in them. Line CH and line EH. So again, line AH. I'll slow down. Line AH. Line CH. And line EH. Does anybody need me to come over and show them in the book? Okay, number 17. What is shown with GD, line GD and line EH? Well, those are in different planes. They don't intersect, therefore they are skew. What questions we have on 9 through 17? Okay, number 31. Skew lines intersect. Never. 2 points are non-collinear.
Sometimes.
Never. So watch. Lucy. Catch. Hold that up. Okay. The tip of the cap is a point. You ready? Can I draw a line for this point and that point?
Yes.
Okay. Wait. What about down here?
Yes.
I can still draw a line, right? Please don't break. 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 How about this? Yes.
Please get up there, please.
What?
You're scaring me.
Okay, so it doesn't matter. 2 points will always be collinear. I hope this still works for her.
Is it Groundhog Day?
What now?
Is it Groundhog Day?
No, that's what we're second.
This is right there.
Well, maybe, okay. Marker.
Happy.
What's the worst throw? Were you
That was
trying?
not bad.
You flung it like a
The
frisbee.
form wasn't good, but the throw, like, it made it to you.
It's true.
Yeah.
Okay, I'm sorry. You're right.
Not all of us play.
Number
baseball.
35. 3 points are coplanar. And we did this yesterday. The 3 gentlemen, we did this. 3 points are always they're always coplanar. What'd you put?
I put some done. So I don't know why.
2 intersecting lines are coplanar.
Sometimes.
And you like that sometimes, brother.
Isn't it true or false?
I thought it was true or false, but
No,
then I read it.
No,
And
it says
always,
sometimes, or never at the top, in the directions.
We're gonna
Oh, I
say
didn't
that.
even read that part.
So, two intersecting lines are coplanar always. Because it does not matter, this line and this line conform. You can always have a plane where two intersecting lines. Okay? So always. What questions do you have?
None.
Okay. What I need you guys to do is open your books to page 12, please. I'm going to do talking. And I'm going to start off our notes a little bit. But y'all are going to use the book because I can't draw well. I am not. Oh, that's why you play football. Okay.
Oh, I can draw.
I could shoot.
Huh?
I could shoot.
Okay.
Can I use the restroom?
I can't shoot.
I'm sure you can. Would you like to?
Yeah, I use the restroom.
Yes, sir. Okay, so here we go. We're talking about, we are 8:29:24. We're talking about postulates and theorems. Okay, so you're on a page that has nothing but postulates on it. And you're going to copy those down. Don't necessarily copy down the words yet. Okay? Let me walk you through this. So first off, what is the difference between a postulate and a theorem?
No clue.
Okay? So, when we think about a postulate isn't proven. Okay? So a postulate is assumed to be true. So I go back to yesterday's example. What's 1 plus 1?
2.
2.
Why? By who?
By gazillions of people.
Really? How?
This is a stupid
Okay.
question. But it's funny.
Okay, I mean, it is a stupid question. Because we all know 1 plus 1 is 2.
Yeah.
But why? Because somebody told us. Have you ever proven it? Not me either. Right? Well, actually, I have. But
How?
it took like 3 blue books and a lot of abstract algebra. You would have a little bit of trouble understanding.
Really?
Yeah, I did it in college. Okay, so it's provable. But right now, you guys assume you're taking the fact that a teacher told you 1 plus 1 is 2. Right? You're taking it on faith. So, postulates, you're taking on faith that somebody knows something that you don't. You're assuming it to be true. So if we give you a postulate, it's not provable. Okay? A theorem, on the other hand, is absolutely proven. Okay? Where did I lost my place?
You would think a theorem would be like a theory.
Hmm?
You would think a theorem would be
Yeah.
like a theory.
These are provable and proven. Okay, so copy down what you think you need to. So we're open on page 12.
Oh yeah, my bad.
No, you're good. I'm good. I'm just helping. Because I'm going to talk about these. You're looking at them in your book. And I'm going to talk to you about what's extremely important and what's not so important. Fair enough?
Fair.
Because you have a video that goes over all these. If you watched it, great. If not, okay, well, you have a video that goes over all these. This is how I'm going to teach you. So it says an expansion postulate. It says a line contains at least 2 points. Okay, that's important. Somewhere you should have in your notes, a line contains at least 2 points. So if I ask you a question on a quiz that might be coming up next Friday, how many points must be considered to form a line? You'd say 2. You need at least 2 in order to form a line. How many points do you need to form a plane?
3.
3. You
I
need
need-
at
oh my
least
gosh.
3 points.
Oh, yeah.
3 what type of points?
Concurrent?
Not concurrent, because
Non-
concurrent means intersecting.
Collinear.
So you think they need to be on a straight line.
No, they don't. That doesn't matter. Non-collinear.
So they need to be non-collinear. So in order to have a plane, you need 3 non-collinear
You
points.
said in order to have a plane.
In order to have a plane, at least 3 non-collinear. And listen, I'm not doing anything other than giving you a simplified version of the postulates in that green box. So this is in your book. You have these. You can look at the words, they say them in there. If this isn't, listen, I'm doing something different, okay? Like, the video is going to be me talking. It's not going to really see me because I'm over here. I'm looking at the same book that you are, and I'm just giving you my spiel on it. I can write all this down if you'd like, but I think you guys are juniors and you're able to write stuff down, yeah?
Yeah.
Okay. Plus, it's in your book already.
3 non-collinear.
Okay, then it talks about space. Now listen, we don't talk about space. It's an abstract thought right now that will be a little bit too confusing. Okay? So, let's go to the line postulate. Any 2 points. Any 2 points form a,
Line.
there you go. If you have 2 points, you can form a
Line.
line. But wait a minute, Miss Rach. Wait a minute. Dog, come on. You're screwing me up here. What if? Oh ho ho. You ready? There's point A. There's point B. Can I have a line?
Yes.
So wait a minute, whoa. It's B's on this plane, A's on that plane.
It doesn't matter.
It doesn't matter. Any 2 points can form a line. Because this line might be on the plane that's going like this. Even though we don't see it, there's a sheet of glass cutting down this way, this way, this way. It's on a plane, but any 2 points forms a plane.
Or plane.
Or no, line. Sorry, you said it right, I said it wrong. Okay, any 2 points form a line. Okay. Now this is where it's a little bit trickier. 3 non-collinear points form exactly 1 plane. 3 non-collinear points form exactly 1 plane.
3 non-collinear points
Form exactly 1 plane. 2 points, you can have a bunch of planes. Okay? 3 points though, and maybe watch this, ready? There's A and B. Okay? A and B are clearly on this wall. Is that correct?
Yes.
Okay, that's the plane. This is the thinnest thing I can find. Ready? Does everybody see the plane? Wait a minute. Are those still on this plane now?
Yeah.
Okay, so the plane's going directly this way. What if I angle it? There's a different plane. What if I angle it a little bit? Oh. What if I go like this and cut it this way? Will that still intersect? Oh, so 2 points have infinite number of planes. Now watch what happens. I'm gonna put it real close. There's C. Let's do that again. You ready? I'm gonna go through A and C.
Nope.
Oh, all of a sudden, beat it. The only plane that works is the wall. That's the only plane that's working and cutting through all 3 of those. When we have 3 non-collinear, because again, this is a line, this is a line, they're not on the same line. Not collinear means on the same. Non-collinear means not on the same. So 3 non-collinear points form exactly 1 plane. Okay, everybody still with me? We're going straight down that green box. Okay, flat plane postulate. Let's see. It says if 2 points lie in a plane, then the line containing those 2 points lie in the same plane. If you have 2 points on a line, those 2 points are in the same plane. So remember how I had the point up here and the point back there?
Yeah.
They're going to be in the same plane.
Yeah.
Even though, but Mr. H, they're on different planes, there's a plane that contains those 2 points. Anywhere there's a line will contain all of the points on that line. Everybody with me? That one's not as important. Okay, so the flat plane postulate, not as important. The next two are very, very, very important. If 2 lines intersect, they form a what? If 2 lines intersect, their intersection is
Intersection
One
postulate.
is a
1 point.
1 point. When 2 lines intersect, it does not matter if one line's in the plane and one line's not. Wherever those 2 lines intersect, they form a point. When 2 lines intersect, they intersect at a point. When 2 lines intersect, they intersect at a point. When 2 lines intersect, they intersect at a point. Postulates, you don't really need to know the name of the postulates. You need to understand what it's saying. Okay? And then the plane intersection postulate. We've actually did this yesterday. This is where Daniel, I keep picking on Daniel a little bit because Daniel said, oh, this wall and the ceiling. And I said, okay, where do they intersect at? He goes, that corner. I'm like, he goes, the line. 2 planes that intersect form one and only one line. 2 planes that intersect. 2 planes that intersect. 2 planes that intersect form a line.
Intersect, form a line.
2 planes that intersect form a line. Create a line. Whatever you want to say, but they make a line. 2 planes that intersect form a line. Okay, so let's go back about what was important from that left side. Okay, you ready?
Yeah.
Lines must have at least 2 points. Plane must have 3 non-collinear points. Any 2 points form a line. 3 non-collinear points make 1 plane, and that's it. 2 lines intersect, they intersect at a point. 2 planes intersect, they intersect at a line. Have I gone too fast for anybody?
No, not at all.
Okay, so,
Okay, now I'm good.
I'm sorry, I missed what you said. Are you good?
Yeah, now I'm good. 'Cause
Okay.
I write slow, so
Okay, but if you're still writing, let me know.
I'm good.
Okay. So, theorem number 1. A theorem is proven. A line and a point not on that line are contained in one and only one plane. What that means is, listen, if I have a line and a point, they're on the same plane. If I have a line and another point, they are on the same plane. Watch what I mean here. You ready? So pause. Don't write anything. Watch. Ready? Let's go to Cooper's. Does everybody see this line right here?
Yeah.
Here's my point. Can I have a plane
Yes.
shearing down through it? How many planes go through that line and this point though?
1.
Only one. It can't go at a different angle because then it wouldn't hit this point.
Yeah.
So if I have a line and a point, it forms one plane. A line and a point forms one plane. Now think about this. Well, what's a line made of? Of points. How many? At least 2. Oh, so really this is 2 points that are non-collinear. Oh. Okay. You'll hear the phrase one and only one a lot throughout geometry. What did I put mark on me? I thought you were trying to be like, okay. I might have. One and only one means exactly one. Okay? If two lines intersect, they are on one and only one plane. Which means if two lines intersect, they're on exactly one plane. I can't
I thought
have-
it was 1 point.
When two lines intersect, they form a point,
I got you.
but two lines that intersect, this line here and this line here,
Okay.
are only on one plane. They can't be on two. Okay?
So two lines that intersect form one plane.
Don't form a plane. They are on only one plane.
Okay.
It's all right. So two
Can you
lines.
say that again? I'm
Yep,
sorry.
absolutely. So the way that the definition reads, or the theorem reads, it says two intersecting lines are contained in one and only one plane. Two intersecting lines are on exactly one plane.
Two intersecting lines form
Are on
Are on. Oh my gosh.
exactly one plane. Okay? Then, two parallel lines are on exactly one plane. If you have two parallel lines, it does not matter where they're at, two parallel lines are on exactly one plane. These two flagpoles that are parallel lines can only be on the plane that's going like this. So two parallel lines,
That's just because they don't intersect.
that's what parallel, they don't intersect and they're on the same plane.
They're just going like this forever.
Forever and ever and ever and ever, like the tracks up here. Now,
Same tracks.
this track right here and this line over here that goes up and down never intersect because it's going left and right, this goes up and down.
Yeah.
But they're not in the same plane,
Yeah.
okay? Parallel means they have to be in the same plane. What questions do we have?
Negative.
Negative is the opposite of. So if it's -5, it's the opposite of 5.
I have answers.
Here we go. Your homework. You have 15. You will always have time in class. Stop it. Homework is page 13 and 14. Numbers 4 through 16 and numbers 19 through 25. Get started. You should. What? Why do I assign so much?
No, I said, how dare you assign so much?
Well, I'm a jerk. What can I say? Go ahead and get started. Now is your time to ask any questions to get going. And if you have the questions, ask them. We're looking for the honesty, right? Love you, kiddos. Yes, ma'am.
Can I go to the bathroom?